So what we have here is f of x equals to negative x squared plus 2x plus 5. And I also have g of x, which is a different function right here, is equal to 2x minus 6. So what we're looking at is we're going to look at different mathematical operations we can put on functions. First operation we're going to look at is just figuring out what f of 2 is. Well, f of 2 is going to consist of just taking 2 and plugging in everywhere that we have an x here. So it would be the negative of 2 squared plus 2 times 2 plus 5. Now again, take note that only the 2 is getting squared here. If it was negative 2 being squared, then we would get 4 right here. But it's just the 2 being squared. So this becomes negative 4 plus 4 and then plus 5. Of course, the negative 4 and the plus 4 will go away. So our end result here is 5. Now, to step it up a notch, now we're going to take a binomial. We're going to take f of x, but we're going to solve it for f of x plus 2. It doesn't change anything. Whatever this f of value is, that's what we plug in for x, even if it does have an x in it. So, wherever I have an x, I'm going to plug in a x plus 2. So it's the negative of x plus 2 squared. Again, the negative's on the outside. The negative is not being squared here. So then it's plus 2 times x plus 2. And then plus 5. So at this point right here, we have our binomial that's being squared. So it's the negative of x squared plus 4x plus 4. And then we distribute the 2 into the next parenthesis. So it's plus 2x plus 4, and then plus 5. Next step at this point is that I'm going to distribute the negative in. So it's negative x squared minus 4x minus 4 plus 2x plus 4 plus 5. So again, I took the negative and I distributed it into everything. Common mistake here is not distributing it into anything past the first term. You want to make sure you're distributing it in to the entire trinomial there. So we have negative x squared. Your terms with the x's, or your linear terms, negative 4x and 2x is negative 2x. And then again, just like in the last problem, which is I've erased, it's negative 4 plus 4, which is 0, and then plus 5. So the solution here is negative x squared minus 2x and then plus 5. The last example we're going to look at here is a composition of functions. It's saying that we want to know what f of g of 2 is. Well, the first thing we do is we solve for g of 2. And when we solve for g of 2, we get a numeric value. And we take that numeric value and plug it into f. So, another way you could see this written is f open circle g of 2. So either one of these, they both mean the same thing. But for now, I prefer working with it in this notation right here. It just helps me see the order in which I'm going in. So this becomes f of, and now I'd figure out what g of 2 is. Well, g of x is 2x minus 6. So g of 2 would be 2 times 2 minus 6, which would be f of 4 minus 6, which is simply f of negative 2. Now, we take this negative 2 and we plug it back into our function that we call f. So we've got negative of negative 2 squared. Now this time we're going to be squaring the negative value. Plus 2 times negative 2, and then plus 5. So this is 4, so it's negative 4. 2 times 2 is also negative 4. 2 times negative 2 is also negative 4. And then we have, this should be plus 5 and not minus 5. I just miscopied it there. So negative 4 and negative 4 is negative 8, and plus the 5 is negative 3. So that's my solution there. One other example type problem that we want to look at is dealing with domains and ranges. We looked a little bit about the other day on absolute values. Now let's evaluate what an absolute value graph looks like and what the domain and range would be there. So, here is my function here. And I want to consider what is the domain and what is the range. Now, the domain of this function, the arrows are not only pointing down, but they're pointing left and right. So, it goes left forever and right forever. So our domain is actually negative infinity to infinity. Or, of course, you could say, depending on how they want the solution done, you could put in the real number system for all real numbers, or symbol, not system, the real number symbol here. For the range, though, the range, typically you read left to right, so domain's no different. You read left to right. But what the big thing about range is, you don't read top to bottom, you read bottom to top, because you want to start with the lower values and work your way up to the higher values. So, for this, the lowest value on this, again, we said it was going to the left forever, but it's also going down forever. So, negative infinity represents no lower bound. And then we go all the way up to 0. Now, 0 is included in the value, so we will bracket the 0 when we go to interval notation with this. So this is a good starting point for section 2.1.